Harmonic series then ends up being a really important series because it ends up being a boundary series, meaning the boundary between series that get small enough, fast enough, where they converge or diverge. So 1 over x, the harmonic series, is the one that boundary series which diverges. Anything that grows faster, so if the denominator grows any faster than 1 over x, all those series converge. They will go to 0 fast enough for the infinite series to converge. So an example was the basal series. So the basal series, when we look at it, this is when the denominator is squared. So this is not exponential, it's quadratic. So we're going to do 1 squared, 2 squared, 3 squared, 4 squared. A basal series happens to have a finite sum. Now this sum happens to be pi squared over 6. Now it's very difficult to figure this out, and we would not be expected to figure out the sum of converging series. That's actually not very important to us. What's important is whether it has a sum or it doesn't have a sum, whether it diverges or converges. Now when we compare the basal series, the sum is much smaller, which is, obviously it's much smaller, it's about 1.5. It's much smaller than the harmonic series because when we compare the two sequences, 1 over x is a red, that's diverging, that's our harmonic series. In the blue is the 1 over x squared, and notice how it gets to 0 very quickly. So this function approaches 0 much faster than 1 over x, meaning that if anything that approaches 0 faster than 1 over x, it will get to 0 fast enough for the series to have a finite sum. So this basal series, it doesn't go to 0 as fast as an infinite geometric series. It still goes to 0 fast enough for it to have a finite sum. And that's because if we compare it to 1 over x, this is our boundary series, the 1 over x function, anything that approaches 0 faster than 1 over x will converge. They will have a finite sum.